the moon's spin. So if you have observed the moon, you might have noticed that the same side of our moon is always facing our planet as it passes through its orbit. This may lead to the question, does the moon rotate, or does it ever rotate? And the answer is yes, although it seems quite contradictory to what our eyes observe. The moon orbits the Earth once every 27 days, and it takes approximately 27 days for the moon to orbit once on its axis. As a result, the moon does not seem to be spinning, but from Earth it appears to be keeping in an almost perfectly still position. Scientists call this synchronous rotation. The side of the moon that faces the Earth is known as the near side, and the opposite or the back side is known as the far side of the moon. Sometimes the far side of the moon can be called the dark side of the moon, but this is not entirely true. When the moon is between the Earth and the Sun, during the new moon phase, the far side of the moon is covered in daylight. The orbit and the rotation are not perfectly matched, however. The moon travels around the Earth in an elliptical orbit. When the moon is closer to the Earth, its rotation is slower than its journey through space, allowing astronomers to see an additional 8 degrees of the eastern side. When the moon is furthest away, the rotation is faster, so an additional 8 degrees are visible on the western side. If you could journey around the far side of the moon, as the Apollo 8 astronauts did, you would see a very different surface from the one that we're so used to here on Earth. The near side of the moon is very smooth. These are basically large dark plains that are created by solidified lava flows. The far side of the moon, on the other hand, is very heavily cratered, relative to the one that we see. The rotational period of the moon wasn't always equal to its orbit around the planet. Just like the gravity of the moon affects the tides on Earth, gravity from Earth affects the moon. But because the moon lacks an ocean, the Earth pulls on its crust, creating a tidal bulge at the line that points towards the Earth. Gravity from Earth pulls on the closest tidal bulge, and this is what keeps it aligned. This creates tidal friction, and this in turn slows the moon's rotation. Over time, the rotation is slowed enough that the moon's orbit and rotation are matched, and the same face becomes tidally locked, forever pointed towards the Earth. The moon is not the only satellite to suffer this friction damage from its parent planet. Many other large moons in the solar system are tidally locked to their partner. The dwarf planet Pluto is actually tidally locked to its moon Charon, which is almost as large as the former planet. But this friction of the spin does not only just affect moons and small planets, it can affect larger planets, just like the Earth. Just as the Earth exerts a friction spin on the moon exerts a friction spin on the rotation of the Earth. As such, the length of the day increases by a few milliseconds every century.